All right, here we go. This video is dedicated to Teddy Power because he noticed I forgot. But anyways, this is the first note of part 2 in the mechanical systems unit. Last we were talking all about different types of forces, and this is more specific. We're going to talk about a few applications basically, which is in a machine. And of course, we don't get too fancy in physics class on the machines, but understand the basics of what a machine is and how it works and why we use them. And you can see there's some for you to fill in here. 5 functions of machine. I believe you have the title, like the first function, changing energy from one type to another. And this is a big deal that we talk about a lot in our energy unit and in our electromagnetism unit, like things like windmills, like changing one type of energy, wind energy or kinetic energy basically for wind, to electricity. Transfer forces, so just change, where the force is being applied from the motor to the wheels. Change direction. So yeah, flagpole, right? These are very simple machines, and this is like maybe to me the biggest one. Change the size of force through mechanical advantage. So using a machine so that you can. This is the one we're going to study the most. Like a small force, a small input force to get a big output force, and we talk about that in this unit. We also talk about it at the very end of the course in the hydraulics and pneumatics part of the course. But the idea of mechanical advantage is, being able to do a big job with a small force. But mind you, there's always a trade-off, right? There's nothing comes for nothing. And then, bicycle gears. Okay, so looking at simple machines, there's really just 2 types. One is a lever I call it, and you can picture, here's an example, right? Probably this one's more like changing the direction of force applied. Maybe it would be difficult for this guy here to lift up this box, right? But by creating a lever, now this doesn't look like it's going to work out well for him, but instead of having to pull up on it, he can push down, put his mass and his weight behind it, right? So he's not necessarily giving himself a mechanical advantage, but he can use gravity to help him in this case. But different levers will give you a mechanical advantage, and we'll talk about that later. So just some language around levers, because we do a lot with them in this unit. The fulcrum is like, in this case, I guess it's right here. It's a pivot point. The load, of course, is whatever's being lifted, and generally, that's the weight, right? The weight of the object. And so most of the mechanical advantage in that we're going to talk about here is lifting things and doing work by lifting something, okay? So the load is generally just the force of gravity, okay? The effort is obviously what you put into it. And so what a machine you want, usually in a machine, is to have a lower effort force than the load. That's the goal. And then when we use the term arm with levers, it refers to the length. If you look where my cursor is here, from the fulcrum, that would be what's called the effort arm, because from his effort to the fulcrum, and then the load arm would be from the fulcrum, I guess the fulcrum's right here, from the fulcrum to the load. So when we say arm, it's a distance. It's just a weird language that comes up when we're talking about simple machines and levers. So levers are specifically 3 types of them, and you'll have a little chance on a little lab to make all 3 and see how they work. But the first class of lever we think is what, like a teeter-totter to me, right? So you've got the fulcrum in the middle. So you've got something sitting there, and this is, of course, is what the guy in the last page had, right? This is the first class lever. In the second class lever, you've got the fulcrum at the end, the load in the middle, and then you've got the effort on the far end, okay? And then the third class lever is just sort of rearranged. Okay, and you'll see, like, the best way to see that is when you actually make them, but we'll also see some examples. I have some examples of levers in the body, because of course our body is nothing but a machine. It's a compound machine. Compound machine, when I talk about simple machines, that's like it has one very small specific function. A compound machine usually has several simple machines put together. We physically, we're compound machines, and there's lots of stuff going on there. And sometimes our body works efficiently, but often it works inefficiently, actually. But anyway, So in this case, 3 classes of the body. So a first class lever in our body would be at the jaw, where the jaw joint itself, right, is the fulcrum, and the load when you're chewing something is at your teeth, but the effort is on the far end in your neck, right? So effort, fulcrum, load. Okay. On your foot, we could call that a second class, because there, if you're lifting up on your tippy toes, or on the ball of your foot, I suppose, there's your fulcrum, right on the ball of the foot. Most of the load would be concentrated. Of course, this is a great example. You see things aren't as simple as just we typically make it, because in the body, we're going to say the load is here. Obviously, what you're lifting is your entire mass, but it's constant. Again, we think of the concentration point or center of mass, and it would be right here at your heel. And the effort that causes you to be able to do all this occurs in your calf muscle, right? So it's a second class lever. Fulcrum, load, effort, in that order. A third class lever could be at your bicep. Now, when you first look at this, you might say, okay, because here's the load at your hand, the fulcrum is at your elbow, and the effort is up in your bicep. So you might say, well, that looks like a teeter-totter type thing. But the important point is that what lifts this load occurs right here, where your bicep muscle connects to the tendon there connects to the forearm. So that is the effort. So the effort's in the middle in the case of your bicep. Okay, so load, effort, fulcrum. So those are the 3 classes of levers, and that's examples of them inside our bodies. Another type of pulley, and you wouldn't think of this as a pulley, but it is definitely a pulley. Another type of lever, you wouldn't think of it as a lever, but it is a pulley. And so you'll have a chance if you want to. So I think the levers lab is one you have to do. Building the pulleys is something you have an option. It's kind of fun. You might have more fun with it than doing textbook questions, but you kind of get that choice later on. But a pulley is a simple machine in which there's a wheel with a grooved rim, carries a rope attached to a load. So obviously inside here you got a grooved rim, and here's the effort, and the fulcrum occurs at the pulley itself, and of course there's your load. So each pulley has its own fulcrum, is its own fulcrum. And you can get mechanical advantage based on the number of ropes pulling. The trade-off with pulleys is that usually you have to do, your effort is over, it might be less effort than just lifting this thing on its own, but it's like over twice the distance. So with a pulley, again, you're never getting nothing for nothing, but or something for nothing. But you do get a mechanical advantage. You don't have to put in as much effort if you have more pulleys lifting up, more ropes pulling up on the load. Another thing is the typical wheel and axle. Of course, there's so many examples of that. That would be, in your car, on your pedals on your bicycle. Like wheel and axle is very, very common. And this is just one little example of one here. So the axle, of course, is the long part, and something's turning, right? So here we have an example where it is a lever. You've got the effort happening on one end. You've got the fulcrum is on the axle itself, and the load is what you're pulling up or down. Another odd part of the gear lever family is the gear. Okay? And you can watch, there's a nice little video on gears. Okay, the second type of machine is the incline plane. And it's nothing like a lever, but it seems like a small deal, right? But you are giving yourself a chance to reduce load. So your goal, your job you want to accomplish, this dude here, is to take this wheelbarrow and get it from the ground up to this height here. Well, he could lift it, but it would take a lot less force, even though over a greater distance, right? Kind of similar to the pulley idea, by pushing it up a ramp. Okay? And that's the incline plane. There are some other examples of that though, we call it a wedge, but if you look at something like this, right, it has two ends that are incline plane, so you are more distance but less force required. And if you look at a screw, even same thing. Here the incline is like on up all the every little turn of the screw is an incline plane. Okay, so that's it for the simple machines. That's the first note. There you go, Teddy. I'm so sorry I didn't have that for you earlier. And yeah, that's it for now. And look into, there's not a whole lot you have to do out of this one. We'll see, we'll get moving on to torque and where you can start doing some calculations and such.